have to record it. Okay, so it should be recording now. Everybody get the message. So, good morning, USA. Good afternoon, Europe. It's fall. It's already getting dark here. It's a bit sad, but we're very happy to see everyone here today for today's fine. The first announcement is that sadly, when I'm the host in the future, there will be no live YouTube streaming because the CNRS, where I have the Zoom license from, does not allow for it. But the last fines, there were always less than 10 people watching it live on YouTube, and 10 of these people, at least nine, between 7 and 9, at least 2 of those were me and other fine organizers. So it was less than 5 people actually. The fines are watched hundreds of thousands of times on YouTube, but typically not live. But later, for people who did not have time, and this fine here is recorded, and I will upload it after the fine onto our YouTube channel, so everybody can still see it. But because the CNRS doesn't trust the public, I cannot do live streaming. Looking back, to last week we had a very nice fine to celebrate 4 years of fine with talks by Eduardo and Sarah Blafahardi on paternal care, especially in primates. We had a raffle of a lot of books that were given to different people that won the books. I think it was a very nice thing and very exciting for everyone. And I hope all these books are on the way to the winners. My book is in the envelope, and I'll bring it tomorrow morning to the post office when I go to the bakery. But today we're going to have a talk by our colleague Yitzchak Mocha, who is going to talk about advancing cooperative breeding research with a comprehensive and live cooperative breeding database, Co-BreeD. And this is, from my point of view, a very interesting and important initiative that he's doing there to get more accurate, high quality data on cooperative breeding, especially in birds and mammals. Yitzchak, he came to Germany, if I remember correctly, 9 years ago to the Max Planck Institute. He's working both in Leipzig at the Max Planck Institute for Evolutionary Anthropology, but also with Michael Grieser and others in Konstanz, the Max Planck Institute for Ornithology. He actually did his PhD supervised by Simone Pica, a dear colleague of mine, who I kind of co-supervised for her master thesis when she did it at the Zoo of Zurich, looking at gesture use in great apes. So that's how the circles are closing. He worked during his PhD mainly with Arabian babblers, so on cognition. But if you work with Arabian babblers, of course, you also are kind of forced to work about cooperative breeding. He has been working together with Michael Grieser, and he is now at the moment busy getting this high quality database together. And I know from our own database on social organization in mammals, how work intensive it is if you want to get a database that is really based on what people have observed and not some assumptions what people kind of believe. And I think this will advance our field greatly, that we will get in the future more accurate databases to ask important questions for social evolution. And cooperative breeding, of course, is one prime interest for people studying animal behavior and social evolution. Okay, with this, I hand over to you, Yitzchak, that I'm looking very much forward to your presentation about the Co-BreeD database and cooperative breeding. Okay, we can see the presentation, but we cannot hear you. And it's not present of you yet.
Can you hear me now?
We hear you now, yes.
Good. Just a second.
So in the meantime, I can.
Okay.
Okay, good.
Yeah. So thank you very much, Carsten, for inviting me and giving me this opportunity.
No, it's good. No, it's good.
the opportunity to present our work on Co-BreeD. So, as Konstanz said, the aim of this project is to advance comparative research with cooperative breeding database. And I lead this project for the last 1.5 years, but I should say that I do it with a very close collaboration with Michael Grisser, Francesca Frisoni, Maike Voigt, and Lucia Brusganin. We all work on that together. So what I will present today is the result of our shared effort. So today I will have 4 short sections. I will start with defining cooperative breeding and convincing you that this is an important or interesting topic. I will then present what I, in my opinion, think it's the main obstacles for comparative research, and how Co-BreeD is designed to address them. And finally, I will present just the very first biological results from Co-BreeD, or what we can do with this type of data. So, cooperative breeding. Cooperative breeding is a care system that has been reported from fish, birds, mammals, many different species of them. And I will use a very broad definition for that at the beginning of this talk. Brown defined cooperative breeding as a system in which some kind of cooperation in breeding activities occur between individuals other than the mated pair. Now, this cooperation can involve allonursing, meaning that different females allonurse each other offsprings, or allofeeding, when group members share food with non-offsprings, incubation in birds, and so on. Now, why is it of interest? In my opinion, because actually it's related to many interesting questions and key questions in evolution. So, for example, cooperation, the most fundamental one. Why individuals help each other? Why do they provide costly parental care to others' offspring? Social cognition. So some authors, as Judith Burkhardt and Carl van Schaik, and Sarah Hardy, as you heard last week, they suggested that cooperative breeding requires that individual understands the needs of others and also care about them. So basically, the prediction is that cooperative breeding species will have more advanced or elaborated socio-cognitive capacities than non-cooperative breeding species. It's also related to reproduction, of course, reproductive skew, and even physiology of reproduction, because one example is that menopause is supposed to be an adaptation for cooperative breeding. So women and whales, female, for example, might live longer than after they stop being fertile, and as an adaptation to actually provide alloparental care to their daughter's offspring. And therefore, cooperative breeding has been studied by many different disciplines, as, for example, behavioral ecology, comparative psychology, and also evolutionary anthropology. And I should say that I think this is a critical point, or interesting, especially interesting point, because the argument is that humans are cooperative breeders. And if you think about it, our babies receive parental care not only from the parents, but also from the grandma, also from the aunts, and from the older siblings, from the neighbor who sometimes just babysit the offspring or just hold it for a few minutes so the mother can do something else. So the argument is that if we really want to understand our own species evolution, we should look at other species, our cooperative breeding species, and to understand the evolution of this care system in general. I hope that's made the case that cooperative breeding is interesting. But what is the problem, in my opinion? And before I will start, I have to say that I will mostly focus on the weaknesses of previous studies today, but that doesn't necessarily mean that those studies are completely not informative, not useful, or wrong or false. It just means that science always starts from imperfect first step, and then we realize, thanks to this first step, we realize what is not really good, and we address it and improve it. So yeah, although I'm going to focus on the weaknesses, we should acknowledge the importance of previous studies. So during the last 20 years, there are increasing use of large-scale comparative analysis. Now, the structure of this analysis is usually as follows. People tend to take a list of species and classify them binary as cooperative versus non-cooperative breeders. Then they take this sorted list of species and put them in their statistical model as a response or even a predictor, but usually as a response variable. And they look for association between this sorted list of species and some environmental factors or social factors or physiological one, etc., etc. And of course, they do that while controlling for phylogeny. Now, the reason why those comparative analyses are so important is that because they can detect very broad biological patterns and sociological patterns that are not species specific. And that's what gives them the power, but what allows that, what enables this inference, broad inference, is their very large sample size. So they usually rely on many, many different species. And in mammal, for example, it's at least a few dozens of species, but usually it's hundreds and thousands of species, up to like 40% of the mammal species. In birds, it's usually much higher numbers, up to 95% of almost 10,000 bird species known. So that's a really large sample size, and it's really nice. And when you see the results from this comparative analysis, you can see really strike patterns, like really nice correlations, quantitative gap between social systems, and so on. So it's very impressive, and no wonder that those studies usually end up with like published in Nature or Science. However, and this is where the problem starts, is that when one actually goes to the data, which hide deep inside the supplementary materials, and here I'm going to focus on the bird case as an example. So many of these large-scale comparative analysis in birds rely on this data set compiled almost 20 years ago. And over here, Andrew classified the care system of all known bird species at the time, almost 10,000 species, and he identified 852 species that breed cooperatively. Now, Andrew did a really, really good job and also honest job, which is very important. And he admitted that only about 54% of the species are based, the classification is based on conventional evidence, like really direct evidence on parental care from wild population. And the rest were classified like because phylogenetic relatedness, or they know to breed in captivity, or unknown. So when you see these strike patterns in birds, you must remember that about 50% of the data points are really, really uncertain. And that's a huge problem. And this is the case with birds. And if you think this is a worry, you should know that in mammals, it's probably much worse. And you can see those two recent discussions about what's going on in the mammal data sets. So last year, what we've done to actually demonstrate that in a more quantitative way, we compared two types of data sets on mammals. The first one is by Isler and Van Schaik, who quantified the amount of alloparental care different mammal species receive. And every species that received more than 5% of alloparental care of nourishing or caring or feeding, we classified it as a cooperative one, just for the sake of this comparison. And then we also looked at the data set by Lucas and Cluton-Brook, who classified mammal species, the same mammal species, as cooperative versus communal versus non-cooperative breeders. Both studies have been published at the same year, so they should represent the same state of natural history literature. And as you can see, the red here is the numbers here are quite high, meaning that, for example, there is 28 species, mammal species, that Eiser and Van Schaik found considerable amount of alloparental care in them, but Lucas and Clutenbrook nevertheless classified them as non-cooperative breeders. And also over here. And if you compare the degree of agreement between those two data sets, statistically, you find that there is a very, very moderate degree of agreement. So again, when we go back to the typical comparative analysis models, we have a big problem at that side of the equation. So now I will relatively briefly discuss what's the problem here. And in my opinion, the biggest problem is that people usually go for the quantity of data rather than the quality of it. So they prefer large samples, which are usually inaccurate because it's really difficult to compile very accurate data on social factors for 10,000 species. We actually don't know much of this data does not exist for many of these species. And they do that, although many behavioral ecologists and statisticians have argued that small and more accurate samples should be preferred. And as said, recently, statisticians also provided statistical evidence, and they called it a big data paradox, meaning that if we rely on large sample size, which we know they are less accurate, we also get less accurate results than if we use much smaller sample size with much accurate data. Now, I would like to give you one specific example of what happened when we take social factors and we calculate them without really looking exactly on what's going on in each sample. And over here in this study, the authors compare the percentage of group with maternity monopolization, like kind of reproductive skew in female, between two types of social system, social species, what they call social species, and cooperative breeders. And as you can see, there is actually a quantitative gap between those two systems, and therefore they argue it's completely two different social systems. Now, the problem here is that when we talk about reproductive skew, by definition, we should only consider cases where maternity could potentially be shared. If you have only one female in a group, if it's a solitary female or if it's a pair breeding, there is no meaning for reproductive skew. There is no meaning for reproductive sharing because it cannot be. So one example for that will be the ground tit. It's a bird species living in the Tibet. And those authors, they look at the broods of this species, and they calculate the percentage of nest or broods where you have a single breeding female. Here is the black thing. And the red part is the percentage of nest or broods with shared maternity. Now that's if you take this sample and you classify, you put it over here, you will end up classifying that species right over here. However, that sample or in that population, you have many pair breeding, so one female, one male, and you have just a few cases when you have one male and several females. And basically, if you want to compare reproductive skew or female sharing, female monopolization, you should only consider, this type of groups. Cursor? Yeah, this type of groups. And when you do that, you realize that about 75% of the broods have shared maternity. Then you should actually put that species over here and not over here. And that's what we've done. So we actually took those species and we recalculate the percentage of group with maternity monopolization, now actually looking at groups and excluding all the pair breeding, and you see that this quantitative gap disappeared. So the argument here is that if we go for social factor, we really need to consider the social composition per sample and calculate very accurate reproductive skew or any other social factors. And that takes a lot of time. So we need probably to have many people or to rely on smaller samples, which are more accurate. So to sum up this part, I think that we have a really big problem at that side of the models, but also in that one. And as of today, in my opinion, the state of comparative analysis is that we actually put the cart way before the horses, meaning that we have very advanced statistical methods, we have supercomputer with a lot of computational power, and we actually have quite a good natural history data, yet we fail to compile this data in one standardized way, which is publicly accessible and is reliable, that actually can be used in those statistical analysis. So that's actually the main motivation behind Co-BreeD. And I will present the structure today, but before that, I should say that this is by definition a never-ending project, meaning that we actively seek further contribution and your feedback for that. So keep it in mind that this is a work in progress. And this is Co-BreeD. So the first thing you can see is that we have bird samples, mammal samples, and human samples. So we actually aim to put in one place standardized biological parameters for all of these taxon, and thereby facilitate more comprehensive view on cooperative breeding across birds and mammals, but also human and non-human species. That's the first thing. And the second important thing is that we aim to facilitate what I call the solution for identification problem of cooperative breeding species. So if you go back to the definition of cooperative breeding, it requires some kind of cooperation in breeding activities. And that's actually quite vague, because what does it mean, some kind of cooperation? And this is not just a case in that particular definition, it's in many different definitions repeated again and again, this unclarity. And the way Co-BreeD addressed this is that we actually do not use any definition of cooperative breeders. Rather, we provide the objective biological parameters. So for example, the percentage of allofeeding, the percentage of allonursing, and percentage of caring, and like this type of parental care. And then users can choose one definition they prefer, whatever they can justify, and sort out the species or the samples that actually fulfill this definition. So they will look only about species that involve in allofeeding, because they do not think that allonursing and allocaring is good enough for whatever reason, and only on those species that involve in more than 5 or 10% of allofeeding. And if they think that reproductive skew is a necessary condition for cooperative breeding, as some have argued, they can also add this criteria. So overall, we provide an objective, yet very pluralistic classification tool for cooperative breeding species. So that's one thing we add. And the other thing that we aim to solve is what I call the continuity problem. And that's related to another part of the definition that I so far ignored. And it's actually that the cooperation in breeding activity should occur regularly at most nests. Again, very vague quantitative term. And again, that's repeated again in many other definitions and was discussed by Grisser and Suzuki. Then they talked about occasional cooperative breeders. And the reason why those people have this vague quantitative terms is that because it's really difficult to put the finger on the amount of alloparental care or incidence of alloparental care that should qualify as species as cooperative breeder. So basically what we have, and this is like our data with bird species over here, and if we look at cooperative breeding as a binary thing, and we ask ourselves, does the species breed cooperatively? We will have some species, the filled shapes, when they cooperative breeder species, and the empty shapes, which are non-cooperative breeding species. However, as said, if we look at the percentage of breeding events in birds that will usually be broods with other parents, we see that there is just a very few bird species that always breed cooperatively. There are many bird species that never breed cooperatively, and there is many bird species that do that sometimes. In one season, they breed cooperatively, and the other one isn't, and so on. So just have a look at how much information is getting lost here or is added if we look at cooperative breeding as a continuous trait and not as a binary one. And therefore, the first data set that is currently under review already of Co-BreeD is about the percentage of breeding events with other parents. And by having that, we aim to actually enable users to study cooperative breeding as a continuous trait and not just as a binary or qualitative categorical trait in their models. And that should really considerably increase the explanatory power of statistical models. So that's what we do in that side of the models. And just briefly, how we aim to actually improve this side of the models. And that's related to the fact that there is a huge temporal and subtial variation in cooperative breeding. So for example, in that species over here, which is the green woodrope, so we have like two different populations in our data set. One of them breed cooperatively at 50% of the time, and there is a range. So in some years, it's actually in that population only 25%, in some other years it's 70%, but there is another population where they actually breed cooperatively in 80% of the cases. And the thing is that what we do here is that we do not look at each species at the species level, but we look at that at the level of samples. So each point here is a sample from a very specific location and sampling date, like a few years. And we have this GPS coordinate and years in our data set. So these biological or sociological, biosociological parameters can be linked to a very specific location and time. And therefore, you can actually look at the very specific rainfall at that location, at that time period, and not use like average rainfall across the species distribution across, I don't know, the last 20 years. Just a few more important features of Co-BreeD is that we do not provide only the percentages, but also the sample size, because it's really vary across samples. We have some species that have been studied for many years, and sample size is like 1,000 broods. And we also have sample like some bird species from the tropics that everything we know about that, it's come from 5 nests. So that will allow user to do weighted analysis according to sample size and the accuracy of the data. Co-BreeD is a peer-reviewed database, meaning that for each sample, there are at least 2 curators of our team that check the data, and then we send it to the original author, ask them to confirm that. And I think this is really crucial because although we are a group of people, we don't know really good these 17,000 mammal and bird species. So we really want this expert's opinion per sample. And we actually change a lot after discussing with the authors about that. And that's, of course, time and resource consuming, but that will give us much more accuracy. And finally, Co-BreeD is a live and open access database. And that's, again, very important in my opinion, because natural history data keep on being published so we can expand with new samples, new population, new species, but also to correct our data because we are humans and we for sure do mistakes sometimes. So that will allow us to make some corrections in the future. So that's very short presentation about the Co-BreeD data. And here I will just show a few of our first results and just to let you a feeling how, if it actually works. So first, the state of the project. We have already this data set, the percentage of breeding events with other parents under review. And we have two other data sets about allonursing and female reproductive skew under preparation. And here is the geographical distribution of our bird samples. So you can already see that we actually cover all 7 continents. We still have many gaps here in North Asia and North Africa and so on, but we work to fill it up. And as of today, we have 117 bird species from 159 population and 176 samples. That means that about one third of our species are represented by more than one sample. That allows us actually to look at also variation within species. And about one third of our samples have been confirmed by the original authors, meaning they are really accurate. Now, what you see here is actually a binary view on cooperative breeding again. Yeah, so the filled circles are cooperative breeding population, and the empty triangles are non-cooperative breeding species. But as said, Co-BreeD allowed to examine cooperative breeding as a continuous trait. And this is how it looks like. So again, look how much information is being added. The light red are actually cooperative breeding population, but they do that less frequent than the very red one. So again, look at those differences. We add a lot more information by looking at cooperative breeding as a continuous trait. This is our mammal sample. Again, we have many gaps to fill, but we are working on that. Yet we have samples from all 7 continents. And again, about 15% of the samples were already confirmed. Now, the first, another thing that we can already infer from Co-BreeD is that we have differences in sample size. So in birds, the median sample size is about 47 breeding events, which is actually quite considerable and also for statistical analysis. However, in mammals, the median sample size is 13, which is really low for statistical analysis. So actually to be certain about the data that comes from that type of samples. And therefore, our first recommendation is that mammal studies need a greater sample size. I know that it's really difficult to do, and it's very easy to say, but hopefully when we publish that soon, you will have another reference saying that and supporting your funding applications. Now I will try to demonstrate how we can revisit evolutionary hypothesis using Co-BreeD data. And I will try to emphasize that the importance of social composition when testing this type of evolutionary hypothesis. And I will do that by discussing like the fundamental problem or contradiction in cooperative breeding. Basically, is that we have all group members providing costly alloparental care, but only some individual in the group breed. So why do they actually provide alloparental care? Why do they help if they do not reproduce themselves? Now, many models have been suggested for that. I will only discuss one model, the limited control model. And actually, I wouldn't even discuss it. I will just discuss its very fundamental assumption, meaning that females strive to monopolize within group breeding. That's the assumption of that model. And it's also argued, not the model, but the author of this model, that it's easier to suppress breeding in birds than in mammals. And why is that? Because in mammals, the embryos develop inside the protecting female body. So if you want to abort the pregnancy, you probably have to actually fight the female, and that will involve physical confrontation. It's more costly, it's more dangerous, more difficult to do than when you have eggs. So in birds, the embryos develop outside of the female body, they put it in the nest, and sometimes they actually have to leave the nest, leave it unattended or unguarded by themselves, and other female group members can come and break the eggs without physically confronting the female. So that's biological difference actually allow us to test this assumption, because if females really strive to monopolize within group breeding, I mean, they really will take any opportunity to do that, then we have a testable prediction. We can predict higher prevalence of reproductive monopolization in birds than in mammals, because it's easier to do that in birds. And Ryan and Cluttenbrook have shown that this is the case, because what they've done is they looked at the percentage of cooperative breeding species with female reproductive monopolization. So they looked at a bird species from literature review, and if 95% of the nest had a single female breeding there, then they consider it a species with a reproductive monopolization, and it's much more common in birds than in mammals, according to their result. However, remember that what they usually do in that study, they look at the entire sample. They didn't look at the social composition within each sample. And as I showed before, it's really critical, because when we talk about reproductive skew, we should only look at those groups where reproduction can be shared, or at least has the potential to do that. And if most of the breeding events are made by pairs, and we still take the entire sample, we will end up highly overestimating the reproductive skew. So what we've done using the Co-BreeD data on reproductive skew, we revisited that study, and we looked at the same species, added even more species, and tested that at the population level. And we focus only on multi-female groups. And when you do that, you see that there is no difference anymore between birds and mammals. Now, another pattern that you can find by using the Co-BreeD data is that when you only look at cooperative breeding species, and you compare birds and mammals with regard to the percentage of breeding events with alloparents, meaning how much a specific species or population breed cooperatively, you see that in mammals, it's about 95% of, the median is 97 over here, meaning that most of the mammals, they either breed cooperatively, and then they always do that, or they are not cooperative breeders at all, and then they wouldn't be in that plot. But in birds, you can be a cooperative breeder, and you can always do that, or very seldom doing that, but usually you do it sometimes. Meaning that if you look at a population of cooperative breeding birds, in many cases, you will have a lot of considerable proportion as pair breeding. And that can actually explain that pattern. Because if you take the entire sample and you look at the all nest, many of them will be pair breeding, and you end up overestimating reproductive skew in birds. So again, to summarize that point, it's really important to look at social composition when you consider reproductive skew. And it's really important to look at things at a continuous way and not a binary, yes or no. And when you do these two things, you can actually avoid a lot of biases that actually show a pattern that is not exist. It's a correlate of that. Now I would like to discuss that result from a different angle a little bit. So again, this is the mammal species over here, and it's the same pattern in birds, but I focus here on the mammals. So this is mammal species, and this is the percentage of singular breeding female groups in a population. So for example, in lions, all breeding events, all litters are produced in groups. So there is always several females that comes together and reproduce. Over here, for example, in that very particular population of Arctic fox, all the breeding events occur at only one breeding female. This is our data, yeah? And what you can see here, the 50% threshold, meaning that all this population, you have more female reproductive sharing than incidence of reproductive monopolization. So basically about 50% of the samples in this figure have much more reproductive sharing than reproductive monopolization. And this is quite surprising, taking that the common view is that cooperative breeding in mammals involve a single breeding female. So reproductive skew in cooperative breeding mammals is assumed to be very, very high. And we show that this is not the case. Rather, when adult females live together, they often cooperate rather than compete. And this is against what commonly actually people think. And now one last result that we can infer from Co-BreeD is that we at the state that we can already somehow estimate the accuracy of current data set. So over here we have the data set about birds. When Downing estimated 4% of the bird species breed cooperatively. And we have the same thing for mammals. From Lucas and Clutenbrook estimated that 3% of the mammal species breed cooperatively. Now, what we can do is that we can look at that portion of species and look which species we also classified in our data set and how we classified them. So this is the Co-BreeD thing in birds. This is the mammal Co-BreeD, and this is the number of species. So you can see that there is a very good agreement between Co-BreeD and Downing. So 71% of the species that we classified as cooperative breeder, they classified as cooperative breeder. We just have a disagreement on one species here and one species here. Now we can do the same trick over here with the non-cooperative breeder species. And here you can actually see that there is a huge disagreement. So about 50% of the species classified as non-cooperative breeder by Downing, we classified them as cooperative breeders. And that's similar to what we find in mammals. Now I want to say two reasons for that difference, and convince you that Co-BreeD is what we actually see is more accuracy in Co-BreeD and how it's evolved. Now, the first reason is, of course, our data set rely on new natural history data. So, for example, one of these species that were classified as non-cooperative breeder by Downing is the red-footed booby, and they published their study in, I think, March 2020, and that paper showing cooperative breeding for the first time in that species was published 2 months later. So yeah, we have more data, and that's just emphasize the importance of having a live data set that can always be updated. Now, the second reason is that we looked at the population level. So we have multiple population per species. And for example, we have this yellow mongoose that breed only in pairs in the Kalahari Desert, and therefore he was classified as non-cooperative breeder here. But a few hundred kilometers south from there in South Africa, the species actually breed cooperatively. So we actually need to look at multiple population to have a reliable classification of species. So overall, if we look at those species that were classified or currently classified as non-cooperative breeders, we provide evidence for a cooperative breeding in about 50% of them. Of course, our data set at the moment is strongly biased toward cooperative breeding species, but that gives us some indication yet that there is underestimation of the prevalence of cooperative breeding species. So it's probably much higher than the 4 and 3% cooperative breeding species in those data sets. So to conclude, my opinion is that as of today, comparative meta-analysis largely put the cart before the horses. We have very good statistical methods. We have supercomputers. We have good natural history data. We still don't have this data in one standardized place where it actually have reliable data. Co-BreeD aimed to facilitate a solution for that. It's an ambitious project to establish comprehensive and accurate resource for comparative research. It provides a unique classification tool of care system as a continuous trait. The weakness of Co-BreeD at the moment is that its sample size. We have a little bit more than 200 species, but if it's expanded, it can actually transform comparative research on cooperation, but also sociality in general. And that's bring me to my motivation to actually present this talk here today, because we actively seek data contribution. So if you work on any mammal or bird species, cooperative or not, it doesn't matter, and you have data about parental care, that we somehow can infer the percentages of alloneuracin or the percentages of breeding events with alloparents, even if it's 0, it's important for us. Please contact us. We would like to have your data, and we promise to offer you co-authorship on our papers. So we are really into fair collaboration. As you can see here, we have many authors who provided data, confirmed their data, and provide further insight about their study system. I would like to thank all of these important animals who inspired this study, the funding agencies that funded my research, also to Shai Markman that funded and worked with me on the conceptual part of this project from Haifa University, and all of the more than 100 people that contribute data so far, confirm their data, give feedback on this project, and so on. So thank you also for your attention. I will be happy to take questions.
Yes, thank you very much, Yitzchak, for a really fascinating talk that I think got lots of us thinking. And we are now having enough time for questions and answers. But before we do this, because otherwise I might forget it, I want to quickly point everyone to next week's talk by Robin Vivian on unraveling the complexities in the song of an endemic Shoda Sky Island bird. So just that we don't forget this at the end. So I hope to see everyone also next week. Unfortunately, I won't be here because I'll be in the plane to South Africa. And now the question answers always goes like always. If you have a question, please write into the chat a question mark. Then I call you up and you quickly say what is your name and what you're working on. And then you can ask your question. We always prefer questions by students. So if you're a student, you can put in brackets an S behind your question mark, that I realize it in case I don't know you. But today we start with a question by Eduardo.
Thank you, Karsten, and thank you, Yitzchak. I I was listening to your talk and pondering and mulling over such important issues that you bring up. We had a wonderful conversation with him before the talk. So I thank you for sharing this interest of yours, this effort. I fully agree with many. I really liked your summarizing of how there's so much value in the research that all of our colleagues have done, over which we can and we hope we can improve. I mean, that should be always the goal, to get it better. So on one hand, I'm very optimistic. Our younger colleagues focusing on how we can get closer to the actual data and data quality. My other part of the brain is wondering how the heck do we provoke the change? And so my common question is more to my senior colleagues in the audience, because we are the ones. It is not our younger colleagues, it is not the researchers, and I'm quoting you, who prefer more data over quality. It is the journals, it is the editors, it is the reviewers, it is the grant reviewers, it is the senior people in this audience who need to decide how are we going to handle this. It isn't the researchers. I mean, you guys are doing what you see. The evidence tells you that if you submit a paper to any of these high impact, more and more low quality journals, you're more likely to get it published if you have a large number of samples or species. So you're not deciding. You don't get to decide to publish. It's the editors, the journals, and the reviewers. And for reasons that frustrate me, puzzle me, nobody seems to care about making sure that the data are checked. I mean, the examples you brought up, oh my goodness, I mean, Tony's there, we did it. We did it for peer living, and the data are just not there. So nothing's gonna change until those who are actually reviewing those submissions say, sorry, go back and get us all the primary sources. Sorry, there are these discrepancies between what the data you use, and start rejecting all these attempts. I mean, it's the natural selection of bad science, as our colleague Richard McElrath published. You guys are doing what you see the system rewards. So that part of me is very pessimistic, because I don't know. I'd like to hear from my colleagues who are we are making these decisions. We are allowing this day in, day out. And I don't know, why don't we have the interest in changing it? Thanks.
I can just say something from an associate editor perspective. So I'm also associate editor in Proceeding B. And I usually send papers to review, and many cases I get very supportive recommendation to publish something, and obviously the reviewers haven't looked at the supplementary materials where actually the data and the real thing is. And when I always look at that, it takes me a lot of time, and always there is surprises there. And I often reject papers because of that, because you see, I mean, although there is a good recommendation from the reviewers, if I don't make sure that they actually looked at the supplementary materials, and the supplementary materials are, I have a strong reason to suspect that, I usually send it back to the authors, ask them to address these issues. And if that doesn't been addressed properly, it will be rejected, although the initial review was good. And my point here is actually twice. The first is that if we really will need a good review process, it shouldn't be voluntary. It should be a paid job, in my opinion. People should do that seriously. Those are the gatekeepers. I do my job as associate editor as a voluntary base, and so is the reviewers. And I don't think we have the time and capacity to do it properly if that's not being paid. And I actually approached the Royal Society and suggested that without getting a really good result so far. But I really think that these things, it's really important to look at everything, and that takes time. And if people like PhD students who work on scholarship or postdocs that have like limited time, they cannot review these papers really good. So I think that that's one thing that should be addressed.
Okay. I'm so free to add a little bit to this. First, I have the feeling it's already getting better. Second, you always have the option to write a commentary and criticize something that's published. But in our scientific culture, you're not allowed to do that, or people are too shy. This is a major problem from my point of view. I had some cases where databases were really bad. I wasn't the expert. I asked people, don't you want to write a report? They said no, they're too scared. Paying referees, I don't think will help a lot because people don't work more when they get paid than when they do not get paid. I have the feeling it would just be the still same referees. They will spend the same time amount of time and get paid. Doesn't matter how good it is. But one suggestion could be to have, like we have ethical referees, to have database referees that we for papers with large databases, we request that like for data on field studies, there is a database referee who is a specialist and looks at this. It's another possibility. Okay, that's just my point of view to this. Very shortly, then we have a question by Michael Grieser.
Yeah, hello Yitzchak. Thanks for your interesting talk. I obviously pretty much aware what you do, but I still have two questions. So the first is a practical one. I mean, based on your experience, what do people that want to do meta-analysis or comparative work have to do when they take a data set that exists out there? To make the call, do I use this? Yes or no? That's the first question. Then I have a philosophical one after that.
They must check the data. This is how it all started. I wanted to use this data set that I was interested in cooperative breeding. I took the data set, I started to check it. I saw one weird thing. Okay, it might be a mistake, might be weird. And then I saw another one and another one, and then I realized something here is not right. So yeah, so they must check the data set. And if the author do not provide references to the primary literature where this data was extracted, don't use it if it cannot be verified. And this is actually a point that is really getting better. So during the last year, there were a couple of data sets that comes out and they had really good references. So that's really getting improved. But in like 15 years ago or so, you couldn't even have the references in many cases. So you just had to believe the authors. Yeah.
More philosophical question that relates to social evolution. So if we want to understand something like cooperative breeding or any other form of cooperation, and you simply have a database where you have like percentage occurrence in a population of whatever trait you look at. Does this really do the trick if we know that, for example, in the case of cooperative breeding, we have this evolutionary and actually also ontogenetic stepping stone thing with family living before? So how do we deal with something like that?
Sorry, I didn't get the question. Where the question is?
Well, so the question is, you still are working against the binary base. You still
Yeah.
say like, okay, cooperative breeding, yes or no, or the percentage 0 to whatever. However, if a social trait evolution pathway is not binary, but includes all the stepping stones, or like in the case of cooperative living in birds, as we showed, it, family living is critical with 0% cooperative breeding. You should then know that and you use your approach. How can we elaborate on that to then actually understand more about social evolution?
If I understand you correctly, what you ask is how can we integrate in one analysis this continuous measurement of cooperative breeding and the binary thing, which is probably a stepping stone before family living, yes or no?
No, not necessarily, but would there be any other, I'm also, I'm not a statistician, so I'm the wrong person maybe to ask the question, or else I would have to answer. Well, maybe that's why I asked the question. And I know you're not neither a statistician, but so from the philosophical point of view, I still think we have to think a bit further. So even if you have then your percentage of cooperative breeding, we still fall short on actually the evolutionary understanding, the evolutionary trajectory going there. So if you do a comparative analysis trying to understand whatever climatic drivers of proportion of cooperative breeding, we still probably still don't understand it. That's what I'm
But
trying
also
to
the
say.
family living thing can be a continuous thing. So in Siberian jays, which are family living species, you might have pairs and you might have families. So that can also be quantified in the same way, isn't it?
Yes.
So the thing is that I think that we're in biology, I think that there is very rarely the case when you have a binary things. Things are quantitative, they are continuous, I think. And classify the testing thing as a binary thing, especially social system, is really tricky. I mean, we can do that, but we must admit that it's very rough estimation. And yeah, so we should aim to do this continuous thing.
I will speak with the statistics nerd that both of us know and see if he has an answer, because I really think that's a kind of what I now start realizing is actually a philosophical problem which we still encounter and we have to solve, because it's, if we look at the ontogenetic and the phylogenetic trajectories over time, just having one parameter with a proportion of occurrence doesn't help them. So it's, yeah. Anyway, but you.
Okay.
Okay, this is interesting questions. From what I understand is when Michael says, if you want to study, does the species have the ability to be cooperative breeding, then the continuous variable might not be so helpful that either they have it or not. But if you want to study under which ecological conditions currently it's more often occurring, more rather than we assume beneficial, then the continuous variable is better. Something like this. I've been thinking about this also with some kinds of social organization. Now, before we come to Sari, we want to also welcome all new people that come to the Fine, and sometimes one might recognize them because they have raised their hand instead of having a question mark in the chat. So I would like to invite, I only see the email, sbh@citrona.com to ask her question. Yes.
Oh, okay. Sarah Hurdy, retired from the University of California.
Okay, I did not see that. Okay.
Sorry?
Go ahead. I did not see that it is you, Sarah. I only saw the email in the chat window, and I did.
Oh, okay. Sure. Yeah. Yitzchak, that was obviously, I mean, this needs to be done. It's important. What Eduardo said is an obstacle for you, but here we go. Have you figured out a way to figure in phylogeny? And I mention this because there are cases that really bother me where it's very, very important. So, for example, you mentioned early on the work on social cognition. And, to me, social cognition is really an outcome or a corollary of cooperative breeding rather than a result and or predisposing factor. And so, for example, if you have an ape that already has rudimentary capacities for theory of mind, for understanding and caring about what somebody else thinks, you're going to have a different outcome than if you have a New World monkey, where, at least in marmosets, Judith Burkhardt has shown that marmosets don't particularly care what someone else knows. But apes, we know they do. So if you start with an ape, cooperative breeding, infants developing, having to depend on multiple others is going to have a different consequence. So where does phylogeny enter into this, or can it, in your system?
Well, in those statistical analysis, phylogeny usually uses just to control, because we expect some closely related species to be more similar. I think that what you just pointed out with the ape thing is that from the very beginning, have something more, like bigger brains or whatever. So I think then you should directly put that other factor into the equation, like, I don't know, brain size, number of neurons, or theory of mind, or whatever. But that will be in addition to the phylogenetical relations that are being controlled for. Like, so you usually have these metrics that you put as a random effect, depends on what your exact question is. But I think that if I know your study, and actually the joint attention paper that I published on the Arabian bubblers actually look at that, whether we actually need the big brain and cooperative breeding for joint attention. I argue that it can evolve in cooperative breeding birds as well, without this big brain of the humans and the other apes had. But that's, again, as said, I think that will be additional biological factors that need to go in.
Thank you.
Yeah, welcome.
Okay, and then now the question by Sari, please.
Hi, my name is Sari Van Balle. I study black howler monkeys in Mexico, their social system. And I very much like your idea of building like this elaborate kind of database with really detailed natural history data available in the literature. But as you mentioned in the beginning of your talk, you have some 5 colleagues that work with you on building this, and then this seems to be focused on one particular research lineage, like cooperative breeding. And so my question becomes, how would it be possible, or how many labor is needed, both in man labor and money funding needed, to repeat that with any other type of comparative analysis that people could be interested in, because it seems such a daunting work to do, and it has been done, but generally on a small scale, and never like, oh, let's look at birds or let's look at mammals. And so that's my question. What do you think, how feasible is that to repeat that?
To repeat that or to expand that? So to repeat our analysis, our data search, or to expand it?
No, to, let's say, a different research lineage, and saying like someone is interested in, I don't know, like movement patterns and what other factors. So totally different, but still a comparative analysis that would rely.
I said, I think that, I mean, people are doing that all the time. The difference between us and other is that we do a quality control of like at least 2, sometimes 3 people checking each sample. We actually try to look at very fine differences between things, like really define everything and have a methodological account for each data set so people can replicate what we've done and so on. So I don't know, it's a lot of efforts, a lot of money. It takes a lot of my time, and and I have one collaborator, Micah Voigt, that actually most of her time invests in contacting authors and trying to get the data from them and verifying things. And sometimes we have exchange of emails between us and a specific author for like 5-7 emails just to clarify one data point. So I don't know, it depends. We aim that to be a really like public resource that everyone can use, and we do as much as we can to make it as accurate as possible. We can do it less accurate, less resources. So I don't know, it depends on.
So the question then becomes, and this is not necessarily directed to you, but like more openly, like, are universities interested in hiring people to do such type of analysis, to building these databases? I mean, I doubt it. So it seems like that you looked out, and that you are in a place that kind of supported your idea, and that there is funding for it, but I don't think it's that feasible in other places, or like to repeat that with other type of analysis. And then I also want to add, and this is again like more of an open comment, in that with these comparative analysis that are generally based on lots of work of other authors that have published their results in the literature, and then they do not necessarily get credited for their work because they end up in supplementary material, because that is where the data is published. And so despite those people that conduct comparative analysis built on the work of other people, these other people do not get the credit, but then the entire system is that with more citations that you receive as a researcher, obviously promotions go with that. And somehow I find this to be unfair. And so it's, and as I think it was Julia Fisher that mentioned like that payment doesn't help. I do think, and I bet lots of us agree with that lots needs to change in academia and all sorts of things to actually move forward and have science move forward. Right. That was it.
I just want to say that I totally agree about the fairness of things, and I sometimes see the same primary literature cited in different data set, always in the supplementary materials. And when you look at that paper at Google Scholar, you see that he was cited like twice, but it was used actually in many different data sets. And this is actually, we aim to change it. So we offer co-authorships for people that confirm their data and contribute the raw data to our data sets. So if someone, we read a paper, we review that, we approach the author, ask him to confirm that actually we understand that correctly, and also to provide the breakdown of the data for year-by-year data. And then we offer them co-authorship. And I think it's fair, exactly because what you said.
What you're doing is very good, but this is one research group, your research group, and then like it remains quite a status quo in all the other ones. But congratulations anyway. Fabulous talk. I enjoyed it.
Thank you.
Yeah, these are important points that Sari raised. Change is always very slow, but we can only change ourselves first before we change others. Now we have a question by Clara.
Hi, thank you. Clara Jones, Clara B. Jones, Social Evolution. Just a comment to Sari. There is a very famous bioinformatic data set published in the 70s or 80s by Karen Stryer and colleagues in Methods in Ecology and Evolution. It's all primates, but you might want to take a look at that. The data set were compiled and worked on at NESCENT and the SCENT at Duke. Now, a clarifying question to the author. What is it that you are mapping across your continuum?
So many things. The first one, the major one that I presented, is the percentage of breeding events. In birds, for example, that can be the number of nests or broods. In primate, usually it will be the infant, because many primates have one infant, but that depends on each sample. So the number of breeding events, or the percentage of breeding events with alloparents. So again, when you look at the population of birds, how many of the nests were attended by the pair alone, and how many of them were attended by a group that provided food together? An example.
Secondly, to use the term care systems, it seems to me disregards the fact that your strategies of reproductive success are what you're looking at when you see any kind of helping behavior. They're just fitness strategies. They're not care strategies, as in altruism.
Okay, well, I think it's a matter of definition or categorization of systems. Yeah, I just followed the one by Kapler, but I actually do agree with it. So we have social systems, we have care system. It's as two different
Yes,
questions.
I know that model. That's not a biological model. That's a model from the social sciences. Anyway, finally, why in your definition of cooperative breeding, why do you do away with or dispense with the diagnostic criterion of reproductive breeding, which has been used since the 1960s, which is to identify reproductive division of labor as the diagnostic criterion?
I'm sorry, I'm not sure I understand the question. So
Separation within groups, reproductive division of labor,
okay.
characteristically has been used as a diagnostic criterion. So separation from breeders, between breeders and helpers, or in social insects, breeders and workers.
I see. Okay, so the thing is that our strategy is that we want Co-BreeD to be used by many different people, and we don't want to bias our data collection according to a very specific definition. For example, one that takes that into account, like considering only a system with helpers as cooperative breeders, or only one that males or females or young or non-kin provide helps and the other ones are not. So we do not use any definition of cooperative breeding. We leave that to users. We provide objective biological parameters. So for example, we take a sample of one species, toucan barber, for example, and we ask a simple question. In that very sample, how many nests have been attended by just the pair, the biological parents? And how many of the nests have been attended by helpers? Like parental care was provided by other individuals besides the parents. That can be young, kin, non-kin, wherever, but non-parents. And so we have this objective thing. What you suggest is another layer of complexity, completely valid and interesting. And yeah, resource dependence. One day we might have a data set about that as well. But at the moment, we focus on the types of parental care. As you can see, that's a lot of work and you already. So we hope to accomplish that.
Yeah, finally, quickly, in mammals, males don't usually co-reside in groups with females, but to emphasize the female groups which occur with some frequency, in a lot of those species, females raise their young separately, and there's no facilitation or helping between females and the unit.
Okay, so that will be like 0% of alloparental care, because we do not study allomaternal care, we study alloparental care.
Okay, thank you.
Thank you.
Okay. Just to mention, in our database, multi-male, multi-female groups are the most common observed social organization in mammals. So it seems to be quite common, and it's also quite different to other vertebrate classes. Now, we said we prefer young colleagues over old colleagues, and I The next question is by KT, which I suppose is Kaya Tombak.
Hi there. I wonder how many years of postdoc I can go and still be a young colleague.
Compared to Eduardo, you will always be young. There's nothing you can do about that.
That's true. Thanks for the talk. I not that you need more on your plate, but I was just wondering because you mentioned maternity skew, I think it was.
Yeah.
Do you have any plans or ideas about how to potentially integrate paternity skew through genetic data? And if you have thought about it, what kinds of challenges are there for gathering those kinds of data from multiple different groups and labs with all, the diversity of methods that are employed there?
Okay, so in terms of plans, there are 17,000 birds and mammal species together. Yeah, so no, I wouldn't go to add another data set. If I manage to get for like a few thousands of those species, that's the percentage of breeding events with other parents and the other nursing data set that we work on, that will be wonderful. Or if I get a lot more money and a research team, then that's going to be another option. Anyway, I did compile a data set about reproductive skew in female, and the reason why I and many previous research focus on the female side is that because it's easier to infer maternity than paternity. That will be one methodological reason. To do paternity thing, that will be really like genetic data, and that will be super tricky. I think you would end up with a very small sample size if you think about like different species. That will be really tricky to do. Also, yeah, in the thing also is that female in a group, you can have one group with one female and 10 males, it doesn't matter. You will only have one breeding event because everything goes through the female. And if you have the other way around, you have a group with 10 males and 10 female and one male, you can have 10 breeding events. Each of them can breed. So I think it's even more interesting to look at the female side for some questions. But I think that the most important thing is the technical one. Paternity will require genetic data, and that's, yeah.
Yeah, fair enough.
Yeah, of course, there's different people working on different databases that can maybe later be combined. We have a database on about 800 mammal species for social organization that shall be published in a similar way to Co-BreeD next year. And Lauren, the fine co-organizer, together with Steve Dobson, who was here at the beginning of the talk, they have a database on multiple paternity in mammals, also looking for all possible mammal species for 56 mammal species. Very little compared to the other databases, but it will also be published relatively quickly, and then people can try to combine these databases. The good thing I have to say is that these three databases I know of, Yitzchak's ones, Lauren's ones, and my own one, they are really databases that focus on high quality data, that is accurate and not on adding as many species as possible to it. So there is a bit of a change, even if it's still within this circle. But we're trying to spread the message further. Like at the ISBE in a few weeks, about Yitzchak and myself will also have talks about this topic.
I would just make a comment on that. So combining database, that can be nice. One has to take into account that we use an approach of like sample-based approach because we admit that there is a huge variation within species. So if you combine a data set with this approach, like sample-based thing, and a species averages or whatever, species level samples, that can be tricky. It's possible, but one should use it with caution, these combinations of things. As I showed, like the yellow mongoose, in one population they breed cooperatively and not in the other one, and in birds it occurs very often. So yeah, what degree of paternity you will put for that yellow mongoose thing? I mean, you have to really try at least to match those values.
Yeah, this is not a problem, especially when you go to life history data like from what is it, Proteria and so on, which is on the species level, and you don't know where it comes from. In our database on the social organization, we try to get the life history data from the same primary literature. In our databases, the social organization and the mating system, it's always not sample-based, but population-based. So at least it's kind of similar. We have every study population, even if there's more than one study on it. Then, of course, the question is, is it the same populations where you have data on cooperative breeding? But one would assume so.
Yeah.
Okay, then I see Eduardo has another question, and after Eduardo, I will move on to Anthony and Eugenia, and I will keep my questions for the very end if there's time. But I have a couple of questions.
Go to people who haven't asked. I mean, there's Tony, there's Eugenia, and these are our regular colleagues. So skip me. I've already asked one.
Okay, then you will be last. So then I go to Anthony, Eugenia, and then myself.
Hi, my name is Tony DeFury from the University of Texas at Austin. Yitzchak, thank you for a talk I quite enjoyed listening to and agree with a lot of what you were talking about. It's challenging.
Yeah, I just will mention that Mike Voigt, my colleague, is here, and one of your samples, I think, almost sure that we have some of your samples in our data set. She would contact you at one point asking to verify the data. So please verify the data. It's not a spam. We are not a predatory journal. Ask you to contribute data.
Okay, great. Thank you. I just had a question, or maybe it's kind of a question and a comment together on some of the definitions of those fields in your database. And, Kaya prefaced this a little bit and talking about reproductive skew, but there's, reproductive skew is really challenging because there's a temporal component to it. And, I think about this on the male side, paternity skew a lot, but on the female side, it's challenging as well, because you've got to characterize breeding events, but over some period of time, if you're going to characterize female reproductive skew. So a female primate who gives birth to a kid this month, when there are 3 other females there, that's not necessarily skewed, right? If another female then gives birth 6 or 8 months later, right? So how do you deal with that? I think that's a complex issue to deal with, maybe more so for non-seasonal breeders where reproduction is continuous, where you can have many primate species, a female gives birth any month of the year. So just maybe a comment on how you deal with that, or how one would deal with that in a database like this, in a comparative database.
It's a great question. And actually, we published a paper last year in Proceeding B, and we have another one under review that actually addressed that. And so, yeah, with the bird thing, it's usually easier because we test like this nest at one occasion. But also in birds, but also in primate, and actually in mammals, it's more common that you have that continuous. So we try to look at the entire sample across year, assuming, in case that we can confirm, that group composition have not been changed. So if group composition is permanent, like in many cases in the common marmosets, we have several papers of that. We look at like those 3 years of data when we know that group composition stayed the same, and we ask how many of these females have been given birth. So we look at the time period, but that's a really valid question that people actually ignore in many cases.
Yeah, and there's an added complication, right? Because you've got amenorrhea in primate species, right? So a female woolly monkey, just as an example, giving birth this year, she's not going to give birth the next year. She's still present, but she's nursing, right? And her kid's still around typically. So there's the same number, even if group composition hasn't changed, there's still the same number of adult females there. But your denominator for your skew calculation is, maybe, this is where I think your point about the importance of group composition and maybe about reproductive status of individuals in that group is an important additional complication for generating a comparative data set. Yeah.
Exactly. And the point is that once you realize all of these complexities and you try to address them, and it's possible, then it's time consuming. So if you go for the quantity of data, you just ignore these things. And as I showed, you end up with a lot of biases in your data up to the point that you find patterns that are, in my opinion, not exist. So it takes a lot of time, and yeah, but it's important.
Thank you.
Thank you.
Okay, then we have a question by Virginia.
Hello, Eugenia Anatoli from Rome. I work on social behavior and reproductive strategies in free-ranging dogs and cats. I am a little, thank you for your interesting and stimulating talk, but I am a little confused about what you said to Clara. You said that the data should be on alloparental care and not on allomaternal care. Then you put in your graphs the lion, but the Serengeti lion, I mean, I think it's an example of allomaternal care, unless you consider alloparental the defense of the males cooperatively. So I'm a little confused on this point.
I think that it's very easy. It's about numbers, not about the sex, okay? So when I say allomaternal care, I mean parental care provided by any other individual beside the biological mother. That can also be other mothers or other females. It doesn't necessarily mean males. So, but it can also include the father, the biological father. That's what I mean by allomaternal care. I think that's how it's usually used. When I say alloparental care, I mean any other individual beside the biological parents, meaning that can be any other female in the group, any other male in the group, as the case with the lions. It's usually other females that provide maternal care. Yeah.
Thank you.
Welcome.
Okay, now I ask one of my questions and give over to Eduardo, and if there's time, I'll ask more. My first question is very critical and maybe not politically correct. At the beginning of your talk with these large databases, you talked about in previous databases a lot of inferred data. What is the difference between inferred data and fabricated data? And do you have an idea when in our field of behavioral ecology it became acceptable to infer data?
Well, you put me on a difficult place. Yeah, well, I think one valid, but I wouldn't do that, but one valid approach will be to use phylogenetic inference. So if you have two species that you know that they come from the same genus and you know the care system of one of them, let's say a cooperative breeder, but you don't know the other one, so you can assume that the other one is a cooperative breeder species. That's valid. You have some justification for that. I do not agree with this approach. I think that it's better to use only the data that you actually know, because as we show, there is a huge variation even within the same species. So it's quite problematic. And at least if you do that, you have to control for that statistically, this type of inference, which is not certain. I wouldn't say that other type of inferences are needed or valid or should be accepted. So basically, when you see these 10,000 bird species studies, I think that you should cut them in half at least.
Okay, so you think if only the meerkats would have been studied, it would be acceptable to interfere from phylogeny that all mongooses are highly cooperative breeders?
No, it wouldn't. I say it's the only way that I think it's somehow valid in a way, but I don't think it's good enough. I think that if you have phylogenetical reason to believe that, that's some type of justification. Whether I think it's justified enough, no, but we can argue about that. We can discuss that. But some people even like infer, I don't know based on what. So if they explicitly give justification in terms of phylogeny, I wouldn't do that, but I can understand their rationale. As I said, I don't think it's correct because obviously even within mongoose, you have this variability, even within the same mongoose species. So yeah, I wouldn't do that. I can understand why some people do that. I do not agree with them.
Okay. Do you have any historical from your literature research? When did people start doing that? Or
When they start doing that?
Who was the first one who came up with this great idea? I study 3 species and make 50 data points out of it.
I don't know. I think it's quite the very beginning of the research. I think the problem again is that I think the first data set that I looked at, the older one, people actually admit the limitation. They say, as I pointed out, Andrew, for example, he admit that, well, I tried my best to classify the care system of all bird species. Many of them are simply unknown. So those and those species are inferred. Do with that whatever you want. The problem starts when people just download a data set and ignore this or do not even read this warning. So, yeah.
Darwin. Darwin.
But he gave a lot of warning, yeah? So saying, I think that can be, and I can give this prediction and so on. He didn't put a data set saying that and that and that the case. Now run statistical analysis.
No, he didn't do that.
So to give a prediction, I think it's completely valid. I did it myself. I looked at one species who concealed sex, or 2 of them, and I made an hypothesis and I give testable prediction, but I put them as a predictions where we will find it. That's how science works. You look at one species, 2, 10, and you made a prediction, but this doesn't mean that's the data.
Yes.
Okay, then we have another question by Eduardo.
I really enjoyed the last several questions and the discussions. So what I was going more than asked, I'll say very briefly, I invite others, please email me if you would like for us to find some time to discuss how there are very simple steps we can take to improve on what all of us here in the audience are interested in. I've been thinking that I don't understand why we cannot get journals to ask the author to sign, the same way that now we need to sign that our procedures have been approved by ethics committees. We need to sign that the data is being shared. Just have the author sign that, yes, I have read what I cited. I'm only citing what I have read, and I have checked the sources. At the very least, that will make some colleagues pause. So let me know if you would like to think together some suggestions that we can then pass on to the journals. More interesting, I think that I'm liking what you were saying just last. I mean, your question, Carsten, we are inferring every single day of our lives. I mean, we're calling it inference, it's induction. I mean, yes, anytime the light in the traffic light goes red or green, I infer and then decide that I can cross the street. So I don't think most of what we're concerned about is not complex. It's rather simple. It takes time, and the system is not rewarding those who are slow in doing what we do. So that's not complex. That's just time, and many of you have said it. And the other piece, now I was going to say it's time, and I lost my train of thought. Yes, I agree. We're all inferring at one level or the other, but let's be explicit about it. I mean, let's just say that I think it is valid that if every single owl monkey social group that's been observed everywhere from Panama to Argentina is found to have two animals of the same size, I'm not calling them male and female, two same size animals that we call adults. If somebody comes and says, I'm just starting a new project with owl monkeys, I'm going to assume that's what we're going to find, okay. But then the problem is that our reviewers, editors, and journals, I'm going to go back to that, are considering this speculated. That's another way in which we describe it. Fabricated, speculated, inferred, induced, you choose. But those ought to be in a different category. And there are mathematical ways in which you assess how robust your patterns are. Let's say you have 3 species that you have actually seen. And you will assume that now you have another 5, 6, 7, 8 that you have not seen, but somebody says they're related. You can test how robust your analyses are by imputing those unknown species to see the extent to which those unknown species ought to be profoundly different from the ones you know to really change the conclusions. So what's underlying all this is that we have to become more comfortable and acknowledge and celebrate our colleagues reporting all the uncertainty there is in everything we do. And I've heard the word statistics all the time mentioned here. Statistics, we're going to statistics for certainty. But go talk to any statistician, their discipline, the definition is we quantify uncertainty and probability. And we're going to them to give us a yes or no answer, ignoring the fact that that's not what they do. They can give us an answer with uncertainty and probability, but then we forget those when we write up, or actually reviewers and editors forget the uncertainty, pay no attention to it. So it isn't complex. It's rather simple. The problem is that we're going to go to bed, not really know how much we've learned. So it comes down to how comfortable each of us is with knowing that we've made progress. But I'm not signing off on feeling like I have wrapped this up, right? Monogamy in mammals evolved because of X or Y, or maybe Z or L or M. We'll figure it out sometime or never. So I agree with all of you, but it comes down to uncertainty, modifying it, describing it, presenting it, and the system rewarding it.
Again, if you look at the scientific system, if you have a paper published in Science based on 40% of the mammals known species that says that monogamy evolved because of whatever, and he used these data sets which are like you can't really trust, or the data was not really there, it was all inferred in some way or another, then you will have problems to publish something else based on 200 species only, which you actually have the data. And as said, statisticians actually ask you and encourage people to use smaller data set, which are known to be more accurate. That's the big paradox data, which is confirmed, like supported statistically, but it's not supported in the scientific system. If you go out to a journal and present a paper of 3,000 mammal species and against like 200 species, which one will be preferred?
Well, but again, we're giving a free pass to those who are the gatekeepers. The authors don't decide to publish. So I don't blame the authors. The authors don't even own the paper, right? The journal does. No, really. Imagine that these were not about monkeys and mongooses, but so much of this science would be retracted if we're discussing vaccines or public health or the economics of war. It's only going through because it doesn't affect anybody's life. But the editors would be, we really have to give explanations for publishing a paper that compares 10 studies on the vaccine with pathetic study designs. And now based on that review, somebody goes ahead and gives $1 billion to a company to make a vaccine. Somebody would be losing a job. Somebody would be in trouble, but not in our disciplines. So it has to come down. It has to be top down. We're not going to see change if we don't see institutional change. And that's where I feel that we have to support our younger colleagues who are still in need I mean, they are not deciding the rules for hiring. So that's where we find ourselves in conflict, because the truth is, yes, of course, I try my younger colleagues working with me to get those publications that the system still sees as better than others. But we are the system. The system is not this kind of alien entity. I mean, we are the university, we are the journal, we are the NSF or the funding agent. It's people like me, it's people like some of you. So, but Karsten is right. You make, I mean, you don't make a lot of friends by being explicit about these things and saying, listen, I'm rejecting, or I disagree giving money to this or that.
Agree.
On the positive side, let's think together about concrete things. It has to be baby steps. You guys are taking them. And really just saying, it's a simple, check a box. I mean, every citation on which we report data has been checked for the data, or it's here, it's there, and there's progress. I agree with what you guys are saying. I definitely see progress.
Okay,
Well, if you want to look on the positive side too, Eduardo, there's lots of progress in people sharing data and sharing analyses. All right. So making your code explicit so you can go through somebody's GitHub repository, look at the code they ran on the data set and see if you can come up with the same answers. I think I've told you we do this exercise in the stats class here every semester, and it is much, much better now getting people to be able to replicate what's published in a published piece of work than it was 2, 3, 4 years ago.
Behavioral ecology and sociobiology, if you do not share the data from the go, it doesn't even go out to review. And I think that's great. But you also need all the journals to do it, because if otherwise authors are going to start finding, well, which is the journal that they don't check the data. But I agree there's progress. I agree there's qualitative change in some of these issues.
Good, I don't see any questions more, so I will stop the recording now that I can also upload it tonight. But we can still, of course, have here an open discussion on these topics, which then you won't be afraid that it will be on YouTube, but I will still tell people that I meet at the ISB in Melbourne what you said. Okay, so but still hope to see everyone next week, but I stop the recording now.